All right, right now we're going to be reviewing some exponent rules so that you're able to do some problems with these. And basically, the number one thing you need to remember is you're never allowed to have negative exponents in your final answer. So that's just something that needs to be taken care of, and we're going to show you how to do that in just a second. But first, let's review some things that you should have already learned, like multiplying exponents that have like bases. So for example, if I'm multiplying a to the x, and I'm multiplying that times a to the y, you notice they both have the same base, which is a. Now they have different exponents, but that's okay. If I'm multiplying like bases, I simply add their exponents. So a to the x times a to the y is the same thing as a to the x plus y. Now, that's a little bit easier to see with variables and numbers. So if I had x to the 7th times x to the 3rd, that's the same thing as x to the, and you can really leave this part out and kind of just do it in your head, x to the 7 plus 3, which is x to the 10th. Okay, so that's multiplying with like bases. All right, now we're going to do the same thing. We're going to divide with like bases. Now, just as multiplication you add, it should seem, kind of obvious that if you're dividing, you should subtract. So if we have a to the x over a to the y, that's the same thing as a to the x minus y. Again, we're going to do that with a variable and some numbers so you can see it. So if we had x to the, we'll say 12th, divided by x to the 3rd, 12 minus 3 is 9. So we have an x to the 9th. Pretty simple. In a second, we're going to get to something that turns out like this. And very easily, we could change this to x to the 3rd divided by x to the 10th. Well, 3 minus 10 is going to give us a negative number. We're going to get x to the negative 7th. Now, there's something that we need to do with this, and we're going to show you what you do with that in just a second. One more problem, though. We're going to try a power to a power. Now, a power to a power would be something like this. A to the 4th, then raised to the 3rd power. Now, just so you know, before we show you the shortcut or the trick for this, that's really a to the 4th times a to the 4th times a to the 4th. And you know, if I'm multiplying like bases, I simply add their exponents. So 4 plus 4 plus 4 would give me a to the 12th. Now, hopefully you can go back here because I don't really want to ever write that out, if we took it to like the 30th power or something like that. So hopefully you can go back here and see the trick. If I'm taking the power to a power, I simply multiply their exponents. So, for example, if I had x to the 7th raised to the 4th power, I could write that out 4 times if I wanted to and then add all the exponents up, but it's much easier to just go ahead and multiply and get, x to the 28th power. Okay? Now, lastly, what if we put a coefficient in there with it? So, something like a coefficient, all right, to a power. Now, just so you know, this 2a to the x and the quantity 2a to the x are two different things. Right here, this x is only affecting the a. Here, the x is affecting the a as well as the 2 because of the parentheses. So, really, this is 2 to the x, a to the x. All right, now, again, that's going to be a little bit easier to see when we put some numbers in. So, let's say we had something like 2x to the 3rd power. Again, sorry, I'm going to confuse you there. The 3rd goes on the outside, right? So, that's the same thing as, and just repeat what it says right here, 2 to the 3rd x to the 3rd. Now, we can simplify 2 to the 3rd. That would be 2 times 2, which is 4, times 2 is 8. Most students do 2 times 3, but that's not what it says. 2 to the 3rd is really 2 times 2 times 2, which is 8, and then x to the 3rd. So that's how you do a power to a power with a coefficient. Okay, now we're going to go ahead and deal with that negative exponent issue that we had. So a negative exponent would be something like a to the negative x. Okay? Anytime you have a negative exponent, you want to get rid of it. In this case, if, and we'll just change colors here so you can see it, we'll think of this as a fraction. If your numerator has a negative exponent, you got to send it to the denominator. So this would end up being 1 over a to the x. And the reason the 1 is up here is because you need something in your numerator. Now, if there were another number up there, you could just leave that there. But if we're flipping this down, we're going to get 1 over a to the x. Now, the same thing happens again if we have maybe something like 3 over a to the negative x. Well, this is negative. That doesn't mean that it stays in the denominator. It means it also gets flipped. So it's going to go to the top. So in this case, we would have 3a to the positive x. So if you want to see that with some numbers and variables, we'll just change it up a little bit for you. Maybe x to the negative third. That's the same thing as 1 over x cubed. Or if we had something like 10 over x to the negative seventh. Got to get this guy out of here. Now, this could just as easily be 1. I'm just, picking a number. It's negative. It's got to go to the top. So 10x to the 7th. Okay? And lastly, one of the probably most missed problems in all of math is anything to the 0 power. So if I have anything in the world, a to the 0 is 1. Most students, they'll write a, or they'll write 0, or they'll write anything except 1. So anything in the world, just making it up. 3x to the 5th, y to the 10th, z to the 14th, to the 0 power. None of this makes any difference. It's 1.